Well, welcome Natural Resources class. This is Minerals video lecture number 4, attempt 2. I already did one of these and it turns out I mistakenly turned my microphone off, so not a great deal. Anyway, so here we go, crack number 2 at this. So last time we were talking about crude oil and who has a lot, who pumps a lot, who do we import from, who exports a lot, those kind of things. And we had been talking also about this concept of proven, possible, probable reserves from your notes right here. And I just wanted to underscore, maybe put some perspective on this whole attempt to assess how much oil is out there. You'll notice from the notes we use, just shy of about 8 billion barrels a year. And if you go down to here to proven reserves, you notice that we have 37 billion barrels in proven reserves. Actually, that was 2014. It was 2018 or 2019, I forget. We're up to 44 billion barrels of proven reserves. And that's actually increasing, as the line says here, levels not seen since 1975. But still, 44 billion barrels, when you consider we use 8 billion barrels a year, that's only 5.5 years of supply. Well, yeah, okay, so we import some. So let's say, just for kicks and grins, let's call it 10 years supply. Boy, if we're going to be out of oil in 10 years, that would be panic time. And so obviously, this proven reserves number grows all the time, and I mentioned that before. But just looking at these numbers of our usage per year and our proven reserves should underscore that. So, there's a lot of oil out there. With prices low like they are right now, there's not a lot of impetus to go look for new oil reserves. And so that proven reserves number is probably going to stay low. All right, so the next thing I want to look at here is there's two questions. Where does it go? Actually, two different analyses of where does it go. If we get a barrel of crude oil, what happens to it? And so to give you a visual, here's this barrel of oil. Again, this would be a 42-gallon barrel if we're talking about crude oil. And you probably guessed that the majority of it goes to gasoline and diesel fuel or heating oil. That's 70% right there. And then other products would include things like coke, asphalt, plastic, grease, kerosene, things of that sort. I guess I have asphalt here. Liquefied petroleum is another piece of that. LP. In the cities, we're hooked up to natural gas lines usually. But if you get to more rural areas of the country, you will see tanks like this around people's houses. Most often, those tanks are filled with LP. And you'll notice down here, LPG, liquid petroleum gas, okay, LPG, yeah, I won't go into that. But anyway, that's another crude oil product. It's not a natural gas, it's liquefied from crude oil, or it's derived from crude oil. And so, those are the places that it goes. Now, if you look, so again, just to give you, and of course, jet fuel here, that's another big single piece. Now, if you go to this list here, though, and you do some math, you add those up, and you see, hey, that's 105%. I think my math is correct. That's 105%. Brian's got a problem. Well, the issue is, no, there's not a problem. This is caused by what is termed refinery gain. Again, refinery gain. So if I were to pull up an image, I should have done this before, of oil refinery, like the Coke refinery that you can see on Highway 52 just south of the cities. Here's what an oil refinery looks like. Okay, we'll just pull these up. These are called fractioning towers, and basically crude oil is heated up. It rises up these towers, and different products are pulled off at different areas along the path as they rise because of different densities and create different products. Okay, well, when you put crude oil in, crude oil is a very thick, viscous liquid, but as you run it through the process of creating these materials, these substances, then basically you're going to create products that have a lower density than the crude oil that they were formed from. And because of this, you have a net increase in volume. So yes, there is 105% of product that comes out of a barrel of crude oil. And that's why the math problem. Again, that's from refinery gain, or a decrease in density causing an increase in volume. Yeah, it's kind of like if you take some saran wrap and you squeeze it in your hand, you are making it more dense, and then if you release it, it will expand because the pressure on it has been released, and that's kind of what's going on here. The second thing is, where does it go? So this is a different look at where that barrel of crude oil ends up, or where products from it end up. And so 63% ends up as transportation, or in the transportation sector, and 24% in industrial processes. So 87% right there, mostly transportation. And so if you look up here, that should make sense. Gasoline and diesel is what most of it is made from. That goes to transportation mostly. Residences, commercial buildings for heat. Now, natural gas heats a lot of places, but not all. And then lastly, electricity generation. Most electricity is from coal or natural gas plants, or nuclear, or hydroelectric, or wind. But there is a little bit that is generated from oil burning, basically. So electrical generation is a small part of it too. And so that's where that barrel of oil ends up going, if you will. In your notes, there's the next line deals with peat and the creation of the different forms of coal from that peat. Remember, you drive off water and concentrate carbon as you go from peat to lignite to bituminous to anthracite coal. And we've already talked about that, and I'm not going to spend more time on that, but it is another fossil fuel. What I do want to shift gears to just a bit now is just a very brief consideration of global warming. Now, of course, that could be a whole class, and so I'm not going to go there. But what I do want to do is really sort of take issue with what some have termed intellectual bullying, if you will. I'm not going to doubt. I believe that the Earth is a bit warmer now than it used to be when I was a child. Although, arguably, by the last 6 years, that maybe is not the case. Pretty substantial research indicates that worldwide we've seen no significant, no temperature increase since, late 90s, 2000, maybe arguably into the early 2000s. The latest springs I've ever seen have occurred in the last 5 years. And so there are places on Earth that are warmer. Our Arctic seems to be. There are places on Earth that are colder. There are some areas in Siberia that are measurably colder now. But just asking that question or saying the things that I just said will cause derision. My remarks to be derided in some parts as people try to put down any suggestion that people and our activities are causing CO2 to be released into the atmosphere and warming the atmosphere, which will be the end of us all unless we listen to them and do the things they prescribe and drastically change our lives to save the world. Okay, saving the world's a good thing. Pollution is a bad thing. Very good. CO2 is a pollutant. It's also a resource. There's research that shows that increased CO2 levels, and it has increased, have actually caused more photosynthetic area, greening of plants and things like that, substantially more. So plants are benefiting from it. We do know there is a greenhouse effect, that you can affect temperature by increasing CO2. The question is, have we increased CO2 that much? And is that greenhouse effect from CO2 significant? Whenever you're, and so there are some articles here that I want you to read. And there's one here. This is actually 2 articles. Now, just so you know, these are coming from energy cooperatives. You say, well, those are power companies. Of course, they're going to put out disparaging, anything that would disparage anthropomorphic global warming. Anthropomorphic, people-caused global warming, okay? Well, but listen to what they say. This is Ed Hopkins. He's the Wisconsin assistant state climatologist. He has degrees in climatology, meteorology. This is Dr. John Magnuson. He takes the so Ed Hopkins takes the position that we're kind of misrepresenting what's going on Earth's surface. That it's not, CO2 is not having the effect people are saying. Magnuson's saying yes it is, and people are the cause of the CO2. Important point here. Both are scientists. Magnuson is a zoologist. He works with the effect of climate on organisms. Hopkins is a climatologist, and he actually studies climate. So when you hear people debate this, and they'll say things like 95% of scientists agree that global warming is caused by people and it's going to be the end of our planet. Well, what scientists are they talking about? Are they talking about political scientists, social scientists, information scientists, or are they talking about climatologists and meteorologists? Not to put any of those others down, but they're not experts in climate and meteorology. And so here is one that is, and listen, you can read for yourself what he has to say. Maybe, arguably, the most significant voice in this could be this gentleman right here. Now, he actually has passed away. So this is, the first one is from 2005 when these debates were a little more common. This is from 2007, so keep that in mind. But this is Reed Bryson. The article mentions he was the 30th holder of a meteorology degree granted anywhere in the United States. So he actually formed the meteorology department at UWS. So this guy's got gravitas. What he says means a lot. And I want you to read that. And he's called the faithful heretic because he doesn't think carbon is a big deal. He thinks water vapor is a bigger deal. And think of it. If our temperature is increasing because of water vapor and not carbon, think of all the effort and energy and resources we've spent researching and trying to control carbon and trying to control people's generation of carbon. And if it's not that big a deal, we've just misused a whole bunch of resources. Maybe the water vapor is from a human contamination. Maybe it is something we can deal with, but maybe not. And so when you hear things like 43 billion tons of CO2 was emitted into the atmosphere in 2019, well, they're searching for a number that sounds big and bad. But when you keep in mind that our atmosphere weighs 5.5 quadrillion tons, 43 billion tons is not very much. It's less than 1% of our atmosphere. And so, pollution's bad. CO2, we don't want too much of it in the atmosphere. But we need to maintain some perspective here. The point of this class, what do we dedicate our resources to? We want to dedicate them to real problems. And here's just another issue. Very often, proponents of anthropomorphic global warming, proponents of people-caused global warming, will use warming and CO2 charts that just look at the last 1,000,000 or 2 years, maybe just a few thousand years. And yep, you can see, well, I'll show you this in a second. You see temperature and CO2 have increased kind of recently. But let's look at what we know of Earth's whole history. So if you look at this, it's definitely confusing. Here, this top line, this purplish one, is CO2. And so here's from creation. And if we go along here, I'm going to trace it. We can see CO2 levels were very high. And then they sort of started to deteriorate. They would peak and valley at different times. Okay, they got real low down here, came back up. Okay, we're 2 billion years ago. Okay, and then 1.5 billion years ago, they peaked again, and they kind of went in this gradual decline. A little bit of a peak there. We get in the Pleistocene. This is the last ice age. Started about 2 million years ago, ended about 10,000 years ago. That's not that long ago. As I mentioned in my other classes, it's actually in the verbal traditions of some of the tribal groups in this country. And so then right here is CO2, and yeah, it's come back up a little bit. But boy, it's nothing like it was back here. So right back here. So here's temperature. And let's see what temperature does. So average temperature is quite low here. It came up, was up for quite a while, and then hit a valley again here, kind of a short valley, came back up, went back down here, another ice age. So here's 1, 2, 3 ice ages, back up and along, another sort of mini ice age there, and stayed along, and then it kind of descended gradually into where we're at now, so that you can see for most of Earth's history, our average temperature was much higher than it is now. And some argue that we're not actually warming, we're actually coming out of an ice age. Well, that's warming, and maybe we're just doing another little peak and we're going to dive back down into it. I actually read articles in Time and Newsweek from the 70s that predicted our decline into another ice age. Okay, so that's some important perspective when it comes to CO2 and temperature. And I want you to also realize that not everybody agrees on why this little increase is happening right here. I'm going to play you a short video clip from a History Channel video called The Little Ice Age. The Little Ice Age was a time roughly from the late 1300s through the late 1800s, some say the middle 1900s, when Earth's temperature was 2 to 3 degrees colder than it is now, and actually at its deepest 4 to 7 degrees Fahrenheit colder than it is now. That's a lot, folks. 1816 is known as the year without a summer. It was so cold that year that it snowed in every month of the year in New England. There was during that summer ice on ponds and icicles hanging from houses during the summer. Of course, crops failed, and it was a huge drama playing out on Earth, not just in New England, but in much of the northern hemisphere. And it seems now there were effects in the southern hemisphere too, recent research suggests. Some suggest it's the cause of the Irish potato famine, the sinking of the Spanish Armada, the ending of the Viking colonies on Greenland, all from this little ice age. But then it came to an end about, as I say, late 1800s, early 1900s. And why is the question? Why was there warming occurring at that period in time? And I'm going to play a short video clip here, and I want you to notice the experts, and they have some impressive credentials, and the different theories on why that warming is occurring or had occurred.
4 decades after the year without a summer, around 1850, the Little Ice Age came to an abrupt end. The dramatic shift occurred over the course of perhaps only a decade. Scientists disagree about what natural force was responsible.
In the same way that the Little Ice Age was probably fundamentally caused by a reduction in the amount of radiation that the Earth, when it ended in the late 19th century, that occurred at a time when the sun started putting out more energy.
The end of the Little Ice Age was caused by fewer volcanic eruptions during that period, but also industrialization and anthropogenic pollution caused by greenhouse gases.
The end of the Little Ice Age, I think, was caused by the same thing that brought the previous 10 cycles to an end, that it's a natural fluctuation, and I think it's the ocean.
Some scientists believe that the oceanic conveyor, the powerful flow that transports heat to northern latitudes, oscillates in strength. They theorize that the most recent weak cycle of the conveyor caused the Little Ice Age, and that the most current strong cycle, still continuing today, brought it to an end.
Well, there you have some reasons why some people think the Earth is warming. And these are some, as I say, some researchers with some fairly impressive credentials. At any rate, I just want you to be able to be free to ask questions. I don't want you to be intellectually bullied into promoting a narrative that maybe you're not sure of. And hopefully that helps. Okay. Just looking at your notes here then, as I mentioned, we're going to go through, we've already gone through peat and coal, and I'm going to do some with metals. I'm not going to do anything with uranium. I'm going to do the last lecture on metals, and that's going to come in just a minute.